Hey guys, it's Andre here, and today we have our third episode of competitive programming. I hope you guys are enjoying the series. I'm actually having a fun time solving some of these problems. We've mainly been doing easy ones. I think I may start solving some of the easy problems off camera to kind of make some progress. As you can see, we've only really solved 2% of the math section. Um, So yeah, I may solve some easy problems off camera and then just do the interesting ones on video. And maybe next episode we'll start that. So today we're just gonna progress with the next one, connecting towns. Um, okay, so city lies on a map. So you have an array, and as always, I'll have the description for this problem, the link to this problem on the description. So each value in the array tells you how many paths are from city n to n minus 1. So for instance, from 0, 0 to 1, city 0 to 1, 3, from 1 to 2, 4, and 2 to 3, 5. So that would be 1260. And then for some reason they want the answer to be modulo 1,234,567. Okay. We must all pass all the towns in numerical order. Okay, so we have the number of test cases, the number of cities, and then the connection. So we don't really care about this, I don't think. The first line, if we were doing this part ourselves, they do it for us. But if we were doing this ourselves, we would read one line for test cases, T, we iterate, then read one line for the number of cities, and then read one line, split that into the spaces as string for the number of routes. And then pass that in. And then we pass in our routes, which has n minus 1, so 4 has only got 3 values. And then, okay, so we need to iterate, over this and multiply them. So then let's see, integer modulo num equals 1, 2, 3, 4, 5, 6, 7. They should fit in still in an integer. So for integer roads in routes, I guess we should do 1,000. Let's just do integer. Okay, yeah, we might multiply a lot of numbers out, so I'll make it a little bigger. Turn result modulo num. So result, we're gonna take our number. It's gonna be 1, so it's the identity value of multiplication, and then we're just gonna multiply by rows. And then let's run this code. So in the first example, it would be 3, and then the second one it would be 2 cubed, which is 8. And this actually failed a lot of test cases. Okay, so time to debug, guys. Okay, so we failed a lot of test cases. We passed one test case. So let's look at what we got here. Actually, I think, yeah, because this is a big number and it's a big computation, I think taking the modulo at the end may fail with precision. So we actually may want to take the modulo operation at every time step and then just return the result. So result equals result times roads modulo number. So we multiply, take the modulo every time, that should still be the same, and then return at the end. So let's run the sample code. That still works. If not, we may need to make this like a bigger number. But yeah, okay, that passed. So it was just because like overflow. Cool. Next challenge. Yeah, sometimes they give you little hints on the numbers themselves. Mary has an N by M piece of paper, and she wants to cut into 1 by 1. And she can only cut one piece of paper at a time. So each cut is a straight line from one side of the paper to the other side. So if you have a 3 by 2, you can cut this way, or this way. Print the minimum number of cuts Mary must make to cut the paper into 1 by 1 squares. So in this case, it would be like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And in here, they're just going to give us the input and we return. So 10 to the 9, so not too big. Print a long integer denoting the minimum number of cuts needed. So we're going to return a long. Interesting. So they give us n by m. So let's see if that's a 3 by 2. I think it's 5. That's a 3 by 1. It would be 2. And they show the explanation here. Okay. What about like a 2 by 2? It's important for us to know before we solve this. A 2 by 2 would be a 2 by 1 would be just 1. And a 2 by 2 would be 1, 2, 3. Okay. 2 by 1 would be 1. What about a 3 by 3? Or a 2 by 3? Let's do a 2 by 3. 2 by 3 would be still be 5, right? It would be 1. I think it would only be 5. And then a 3 by 3, I then believe it would be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it seems like our answer is going to be a long result is equal to long n times m minus 1. Right? 3 times 1 is 3, minus 1, 2, 6 minus 1, 5, 4, 9 minus 1, 8. We need to make sure to cast it to a long and then subtract the 1, avoid overflow. Okay, we got some failing test cases. What we could do is actually then do a long n times long m, multiply that out, and then we subtract 1. And then we pass. So I think with a lot of these problems, it's important to know the sizes of your numbers and your digits. Because if we do an integer times an integer and it was overflowing, then we were casting to a long. So what I did here is I cast it to long first, so we have more bits, we can hold bigger numbers, and then it won't overflow when I multiply them out because it will be long, and then we subtract the 1. And I think, yeah, this episode was a little bit longer today. Had to do a bit more debugging. Those digits were getting us, so yeah, it's good. Something to keep in mind, you know. Sometimes in software you don't think about this as much because it's not an issue, but especially with competitive programming, you have to be aware. So, well, I hope you guys had a good time and this was insightful for you. You know, you can start thinking about these things as you solve your problems, and I'll catch you guys on the next one.